Everyone can take a look over here, please. Like I said, we're going to be talking about ecology today. And ecology is the scientific study of interactions between different organisms and between organisms and their environment or surroundings. Just like how we talked about before, good science is good observation, and good observation is good note-taking. So what I would like you guys to do is we're going to start things off today by writing this down into our notes. I'll give you a minute or so, then we're going to talk about it in a little bit more detail. We're doing everything electronically this year. So if you guys can open up like a Word document or like a Google Doc. Sure, whatever works best for you. What's that? Google Docs will work, Word document, whatever works best for you. Do me a favor, at the top of your notes today, please title it 9/14 Notes, Ecology.
Different sections on the sheet of paper, because it's going to be like my entire...
If you'd like to do it on paper, you can.
No, I mean on this, like it's going to be like 9/12, and then my notes for 9/12, and then like 9...
Sure, whatever works best for you.
Right.
Yeah, we just want to have a good way to organize this for when we need to find it.
I feel like a big boy.
That'll work.
What do you want? Write the whole thing?
What's that? Yeah, write this down. Just one sentence.
I just take a picture.
The scientific study of interactions between different organisms and between organisms in their environment or surroundings. No, I need you to write this down. What's that?
I just found it on.
Okay.
If you want us to call it. Just write
So I want you to write 9/14 Notes, Ecology.
Okay.
Yeah, I'm terrible at copying stuff.
That's okay. Take your time. We're going to learn these skills as we go. Take your time.
It's kind of scientific, but
That's okay. It's A-okay.
oh, interaction.
Hold on.
Oops. I'm glad that I studied how to type. I'm glad
Jacob, you doing okay back there?
Yeah.
Mr. Back, do you know how to type without looking at your screen or the keyboard at all?
Is that a key?
What's that?
Is that a key?
Yes, Ecology, ecology.
It is a very useful skill to be able to type without having to look.
That's right. Hey, let's make sure that we're quiet so we give everybody a chance to write this down. All right, while you guys are wrapping up those notes there, I've got a couple questions for you. So we know the definition for ecology. I want to get some ideas from you on what you think about when you hear this kind of terminology. So Chaz, why don't we start off with you? Ecology, the scientific study of interactions between different organisms and between organisms in their environment or surroundings. So is there like anything that kind of comes to mind when you hear about something like
The
this?
first thing that comes to mind when I hear organisms and environment is animals.
You think about animals, okay. Do you think about just animals hanging out? Are they working together? Are they working apart? What are they doing?
I would think about how they interact with each other in their environment.
Very, very good.
Like the food chain and stuff.
Okay, that's a great launching point. One of the things that we're going to be focusing on a lot today are these symbiotic relationships between organisms, right? But the very first thing we need to understand, sorry, excuse me, the very first thing we need to understand are what are these organisms, right? So if you guys could take a look up here for me. Also, for those of you that prefer to have copies in front of you, you'll also find that the notes are posted in Google Classroom. You can follow along with me there if you prefer to have it in front of you as opposed to up here. So what we need to talk about first are producers. Producers, sunlight is the main energy source of life on Earth, also called autotrophs. They use light or chemical energy to make their food. So plants, plant like produce, like algae, so on and so forth.
I'll write that down.
Now, yeah, please go ahead and write this down to your notes. While you guys are writing that down, I'll talk to you a little bit more about this. And we're talking about autotrophs, which is the terminology that I want us to use moving forward. We're talking about organisms that can't go and get their own food. They have to make it, right? So Matthew, if I were to ask you, is grass a producer, what would you say?
Yes.
Absolutely, right? It makes its food. Colin, flowers. Are they producers?
Producer,
Yep, very good. Jacob, what do you think? If I were to ask you a tree, is a tree a producer? What would you
What about
say?
Venus flytrap?
Yeah, absolutely.
What about
I had another student ask me that today. Save that question because we are actually going to talk about that. We're going to have Venus flytraps in class that you'll have a chance to interact with. Yes, we will.
It's so fun to
When
do.
you
Yes, we will have them in
You're
class.
very comfortable.
Whoa, hold
What did you
on.
say?
Hold on.
We would have Venus flytraps and we take them
I
back to our
heard the
dorms.
last one.
Very cool.
Do we take them back to our dorms or what?
No, they're staying here.
No.
So, Nathaniel,
Yeah.
we said that grass is a producer. We said that flowers are a producer. We said that trees are producers, right? So, Nathaniel, my question for you, what about a lion? Is a lion an autotroph?
No,
No, it's not. Why?
because it needs meat to survive.
That's right. Does it make that meat or does it have to go find that meat?
It has to find it.
Yes, it does. And we call those types of organisms heterotrophs. Am I going too fast?
Yes.
Yeah.
All right, well, we'll move on to the next slide here in just a moment. Go ahead and get down what you need, and then we will...
Difficulties.
Oh, I already know.
That's
that
fine,
one.
take your time.
I already know that one. I'm just gonna write producers. Just as a way to keep it, but I already guessed it. So like, history.
What's up, bud?
Did you actually know how weird those are?
What's that?
The Venus flytraps, you know, like how weird those are?
They don't close over like. I mean, they close over time. It's not like an alligator thing so good like automatically.
Well, you have to freeze
Well,
them.
no, they're very cool. Let's keep your voice down, because I'm going to give everybody a chance to write down the notes.
You have to freeze them.
We're learning science in here.
Yeah. Because you can't like water them on top. You have to like go from the bottom.
Yeah, we will be working with Venus flytraps in here.
I'd like to help
Yay.
them because I already have one at home.
Very cool.
So. Well, anyway, I'd like to help.
All right, are we ready to move on?
Yeah.
All right. We know what producers are. And Jacob, what's another name for producers? You got it? Yes, very good. Autotroph. We're also going to be talking about heterotrophs, or consumers. Organisms that rely on other organisms for their energy and food supply, also called heterotrophs. So I'd like you to write this down. While you guys are getting that down into your notes, we're going to talk about that a little bit, right? So Dade, when we look at organisms like up on the TV, right? Would you say that the cow is an autotroph or a heterotroph?
Right. It's a heterotroph.
It is a heterotroph. Why is it a heterotroph?
Because it,
Does the cow make the grass?
no.
Does it have to go find the grass?
He has to eat it and he makes energy out of eating something.
Yeah, you hit the nail right on the head. Perfect. He's using that energy that he has to go and find, right? So the cow is a heterotroph. So Moon, what about a bear?
A bear?
Is it an autotroph or a heterotroph?
Heterotroph.
Good. Chaz,
There's a bull.
is a blueberry an autotroph or a heterotroph?
A blueberry?
Yeah.
Autotroph.
Very good. It's an autotroph. I'll give you guys a moment to write this down.
Oh,
And we're going to move on. You guys are doing a great job so far.
And then there's a third one. I don't remember the third one.
No, you're thinking about the next couple slides.
Oh,
But, there are two types of organisms, autotrophs and heterotrophs.
Oh, yeah.
Now, there are different forms, but we're not going to be covering those today.
Okay.
I think I used the color right.
Well, you know I know this one like from the back of my hand. So
Good. Good.
it's easy for other stuff to do just one right there.
Oh, that's a good way to think about it. All right, looks like we're ready to move on.
Yeah.
So we know autotrophs, we know heterotrophs. And Moon, what's another name for a heterotroph?
It's consumer.
Very good, it's consumer. So, those two types of organisms have a very specific relationship with each other, right? Colin, what is that relationship between autotrophs and heterotrophs?
Oh, the heterotroph. Oh, wait, you're talking like symbiotic. That's right.
So don't worry about this yet. We're going to get to here in just a second.
No, I mean,
But we just learned about autotrophs and heterotrophs, and they have a very needed relationship. What is that relationship?
Are you talking about abiotic, symbiotic?
No, we're not there yet. I'm asking you, what relationship do autotrophs and heterotrophs have with each other?
Oh, the autotrophs. Yeah, the autotrophs create food for the heterotrophs.
Okay, more or less. Dave, I saw that your hand went up.
I was basically going to say the same thing, where it's like autotrophs kind of, they make energy for themselves with the sun and stuff, but they also give energy to the heterotrophs too. But
Yes, they do.
Basically.
So, Jacob, go ahead.
Well, I mean, they both need energy of some sort. Like,
They do need energy of some sort.
sunlight and that.
All right, so let's piggyback off of that, right? Autotrophs make their food using sunlight, right? Bring that chemical energy. When we look at heterotrophs, where do they get their energy from?
They get their energy from other organisms.
From the autotrophs, right? So here's the question. All right, Matthew, you're going to help me out with this one, okay? I'll turn over this way, I'm going to tell you. Okay. Autotrophs and heterotrophs have a very needed relationship with one another, right? The heterotrophs depend on these autotrophs, right? No autotrophs, then that means that there's no heterotrophs, right? Do the autotrophs depend on the heterotrophs at all?
No.
Yeah.
Yes.
Yeah.
Okay. Yes, they do.
Fertilizer.
What's that?
Fertilizer.
Well, yeah, to a certain degree, absolutely, right? Actually, that's a great segue too. So when we look over here, we're going to talk about the relationship between biotic and abiotic factors, right? Again, all of these things tie together to form the environment. So when we look at biotic, we're looking at organic matter, living things, oysters, blue crabs, zooplankton, phytoplankton, jellyfish. The list goes on and on and on. You don't need to write this down, but we are going to talk about it, right? When we look at abiotic factors, we look at things like climate, non-living things, sunlight, temperature, humidity, soil, blah, blah, blah.
Fertilizer.
Yeah. So, I got a couple questions for you. We're going to see if you can accurately define the difference between biotic and abiotic. So, Moon, you tell me, what does biotic mean?
Biotic means anything that is living and
Good. And abiotic means?
it means anything that's non-living or is. It can affect biotic matter, but it is not in itself alive.
Yeah. Okay. That's a good way to phrase that. So, Jacob, I got a question for you. Is a flower biotic or abiotic?
Abiotic.
A flower is abiotic because all flowers are dead. There's no flowers.
Oh, biotic.
Ah, there we go. Good job.
Was it the
Oh, we're actually going to expand on that idea in just a second. Chaz, is grass biotic or abiotic?
biotic?
Very good. It's biotic. Nathaniel, rocks.
Abiotic,
Very good. Why abiotic?
because it's a mineral.
Is the rock alive?
No.
Has it ever been alive?
No.
No, it hasn't.
Yeah.
One more question. Dave, you tell me, water, biotic or abiotic?
Abiotic.
Very good, it's abiotic. All right, so here's the tough question, all right? And if you know the answer, don't blur it out because we're going to talk about it. And I have all eyes on me. A dead animal. Raise your hand if you believe a dead animal is biotic. All right? Raise your hand if you believe a dead animal is abiotic. Oh, divide in the room.
I think it's really-
Tell me why you believe that a dead animal is abiotic.
Because of non-living.
It's non-living, okay? And Omar, I think you rose your hand for biotic, correct? Omar, why is a dead animal biotic?
That's a good question.
It is a good question, isn't it? Moon, can we get a good answer?
Because it's still organic matter that is, even if it's decomposing and the animal itself is dead, it is still a biotic piece of.
Yeah.
matter, therefore it still has functions that it goes through, even when decomposing.
Yeah, you added a couple extra details there, but yes, that more or less that is correct. A dead animal is still biotic. Now, I understand the confusion, right? Because we just said non-living things are abiotic. But that deer was alive. You don't get to be both things, right? The rock was never alive. It's abiotic. The deer was alive. It's biotic, even when it's dead. Yes?
Technically, there are rocks that are biotic. Fossils.
To a certain degree, I suppose.
Okay, so you missed, when you were covering on the producers and consumers, you forgot one huge class.
What's that?
The decomposers, the fungi,
I already talked to Dave. We're not going to learn that today. We're going to get there. Just
okay, this
hold on.
I have it on your list.
Yes.
I have it listed, right?
It's still biotic.
A what?
A dead human is still biotic.
Still biotic. When you go out hiking and you see a tree that's fell in the woods and it's rotting and there's all these bugs crawling through it, that tree was alive. It is biotic. All right. So now we're starting to understand a little bit more of these relationships that happen between organisms and their environment.
Smash a rock.
We're not going to cover that. It's a
Does it
day.
turn biotic?
Niche.
No, we'll be covering that a different day. All right. So this is your next note. So I'd like you to please write this down.
Okay.
Because now we're starting to put those relationships together, right? We're going to give them names. Symbiotic relationships. Symbiosis, an evolved interaction or close living relationship between organisms from different species, usually with benefits to one or both of the individuals involved, not always. We'll talk about that in more detail here in just a second. But I'll give you a minute to go ahead and write that down, and we'll continue. Sorry, I'm on your way.
Yeah.
We're in 6th period, correct?
Yes.
Yeah.
Thank you.
Yeah. Okay, I am really accurate. Yay. I always get nervous when I'm typing and not looking at it because I'm afraid I'm going to make a mistake, but then I automatically just correct that mistake without even thinking.
Yes.
Good going.
What happened to my chemistry and biology textbooks from last year?
Anything that was left in class just thrown away.
Dang.
Okay.
Wow. He's dropping straight facts over there.
Another minute or so. All right, looks like we're all pretty much wrapping up. All right, there are 3 different types of symbiotic relationships that we're going to be talking about. Does anyone know what those 3 types are? Go ahead.
I don't remember the exact names, but I do know what they are.
Well, we're not looking for that right now. Right now, we're just looking for the names. We'll come back to that.
I believe parasitic.
Parasitism.
Parasitism, can't get the word, but they both support each other.
Okay.
And then they,
Well, hold on. Right now, we just want the names.
I can't get.
Jacob.
Multiple.
Commensalism.
I don't know how to say it. It's a mutualism.
Mutualism. And what's the other one?
Mutualism.
Commensalism. And parasitism. It's almost like you looked it up. Yeah, those of you that don't go to class, you would have already seen it.
I couldn't get.
Parasitism, mutualism, and commensalism are the three different types of symbiotic relationships that we're going to talk about. And we're going to start off with parasitism, because that's the worst one, so why don't we start there, right? I'd like you to write this down in your notes, please. Parasitism is a relationship where the symbiote lives in/on the host. This symbiote, or parasite, benefits and the host is harmed. So while you guys are writing that down, I'll talk to you a little bit about that. So when I was younger, I had lice, and it sucked, right? For me. The lice were doing great. They had food, they had shelter, they even had transportation between environments. But for me, it was terrible, right? The way that a good way to kind of remember parasitism is, imagine, you were invited to the party, but, you don't get to eat any of the cake.
Dang.
I know, right?
Oh,
Terrible.
I always have.
Actually, worse off, you do get to eat the cake, but the cake's made of mayonnaise.
Well, no, I can't eat the cake anyways because it has wheat milk in it.
Is Venom? Is the movie Venom? What relationship is that?
Well, I mean, that would be a mutualistic relationship, but let's stick with these environments.
Lice are the worst. I had to cut my hair, and this took 3 years just to grow back to this length. If it was, I would have had double the length now. I'm upset. And the thing is, they said, oh, you have to cut your hair to remove lice, and you don't.
Well, maybe that was the only one.
It really wasn't.
Yeah, let's make sure that we're quiet, because we want everybody to get their notes down. You guys another minute or so? Actually, it looks like most of us may have already finished, so don't worry, we're not moving on. This will be the last slide that we cover today. So let's see if somebody else can give me a different example of parasitism. Jacob, can you think of an example of parasitism besides lice? An instance where one organism gets all the benefit and the other one's harmed. What's that? Ticks. That's a great example. Omar? Mosquitoes. Chaz?
Fleas.
Fleas. That's a good one. Dave?
Virus.
Um,
Or no, wait. What am I thinking? Disease, is it, or is that?
You're not wrong, but you would have to specify like the type of virus that you're talking about for that kind of situation. But we can work with it.
Qualify.
Daniel?
Those mushrooms that feed on the ants and cicadas that mind control it.
Yeah, you're the second student to talk about that today. The organism that you're thinking about is a spore, but more or less, yeah, we can work with that. Moon?
COVID-19.
Okay.
Sure.
So-
I had to say it.
We get the idea, right?
Yeah.
One gets all the benefit, the other one's harm.
Oh,
Now, the interesting thing about this, right, is that the parasite doesn't want to kill the host. It's not intentional. For example, a tapeworm that's living inside your stomach, eating all your food, is very happy living inside your stomach. It gets shelter, it's safe from the environment, it gets to make babies, it's eating all this free stuff. It's great, it's like living rent free.
Wow.
The byproduct of the organism existing with this organism, however, results, in
Death.
death.
Dog.
So it's not like they want this to happen. It just kind of happens that way, right? Because think about it, right? Why would they want to kill their free meal, right?
How did they get in there?
What's that?
How did they get in there?
How do they get there? I don't understand. What do
How
you
did
mean?
the tapeworms get in there? Whatever.
Oh, I mean, normally it's consumed, or some situation. Like for example, you can step on a rock as long as there's some kind of opening to the skin.
Ah.
Right.
Yeah.
Normally starts microscopic and then
I know.
goes
Oh.
way up. All right. Are there any questions, comments, or concerns about parasitism?
Oh,
Yes.
what should you do if you have a parasite?
Well, I mean, it depends on the parasite, right?
I'm talking specifically like ticks.
For ticks,
Right.
the best thing to do is to burn them off because you don't want to leave the heads in. Good thing about ticks though is if you find them within 24 hours of them getting on you, you're still in the clear. But you don't want to have ticks.